Number 15. It looks tricky, but notice if we have something in front of x squared, more than likely that's a greatest common factor is going to factor out. Yes, all of them can be divided by 3. So we factor out a 3, we're left behind with an x squared minus 4x minus 12 equaling 0. So all we're going to focus on is this, because technically if you divide by 3, you're going to get this piece has to be 0. And think about it, 3 times this piece has to give you 0. That means this piece has to be a 0. So what would make x squared minus 4x minus 12 0? Well, we work on the 12. We think, hey, let's break it down. 1 and 12, 2 times 6, 3 times 4. It is negative 12, so one of the pieces is negative, one is positive. Basically, so we're looking at subtract them. Difference there is 11, difference here 4, difference here 1. We want a difference of, according to the middle, 1 and negative 4. That means the negative's on the 6, positive's on the 2. So this x squared minus 4x minus 12 breaks down to an x plus 2 times an x minus 6 equaling 0. Now you can put the 3 back out here, but it doesn't make any difference. 3 times something else equals 0. That means either this piece has to be 0 or he has to be 0. One or the other. So let's figure out what would create him to be 0 and what would create him to be 0. Well, if I subtract 2, if x is negative 2, that piece would be 0. Or my other option is this guy. If he comes out to be a 6, that would create a 0. There you have 15. 16, piece of cake. It already broke it down for us. It says, hey, you got this thing, x plus 2, times this thing, x minus 3, times this thing, x plus 1 equals 0. So either this piece has to be 0, he has to be 0, or he has to be 0. So we set each one to 0. Solve this guy. Negative 2 is an option. Take the x minus 3, set it equal to 0. Then move the 3 over. 3 is a possibility. And finally, the x plus 1, set him equal to 0. Negative 1. So it's either that, or this guy, or this guy.